Okay, so we're looking at number 11 here. We've got coherent monochromatic light, so we just got some laser light, and it's specifically a violet color. So we know that the violet end of our spectrum, like kind of purpley end, is somewhere around 400 nanometers invisible, or in the visible spectrum. Red is around like 700, 750 nanometers. So let's just pick 400, whatever. And it falls on a narrow slit, so singular, of width 1 times 10 to the minus 3 nanometers, or millimeters, excuse me, which means that this is really like 1 times 10 to the minus 6 meters, whenever we convert that milli. So what we have here is, let's see, a slit width D equals 1 times 10 to the minus 6th. And then this here is 38 meters away from a viewing screen. And on that viewing screen, we have our central peak, which will be very large for a single slit. And then there will be smaller peaks after it, which will die, but they're much smaller for a single slit. And remember, this first dark spot right here takes place at a plus lambda and a minus lambda. So one full wavelength, or a 360 degree shift, or a negative wavelength of 360. Just symmetry. So if we're kind of looking at this here, and forgive my drawing, it's not the best. If you want to figure out the angular width of this angle theta here, you can find this because you know this is a dark spot. So for a single slit, you can say d sine theta equals m lambda for a dark spot with m equaling 1. And in this case, we simply just go solve for theta. Your theta is going to be an arc sine, so theta will equal an inverse sine or an arc sine of 1 times lambda, so whatever it is, we just picked 400, divided by d, which is 1 times 10 to the minus 6th. You want to be careful here. Well, I put a 400 here. What I really meant to put was 400 nanometers, so that's 400 times 10 to the minus 9th. Or if you wanted to convert it, you could say it's 4 times 10 to the negative 7th, however you'd like to do that. You get an angle there, and then the only thing you need to remember is that this angle went up and it went down, so you should double that angle to get the whole thing. Okay, so this times 2 gives you your angular width. If you want to figure out what your actual linear width is, then what you're actually looking for is what is this gap along the side here. And you want the whole thing, but it's kind of easier just to find the upper length first, because since you have the angle here, this is your opposite side you're looking for, and you know the adjacent side, it is 38 meters. So if you know the adjacent side and the angle, you can use tangent to go ahead and figure out what that opposite side is. You can simply say that 38 times the tangent of whatever your angle was that you found here, not the whole thing, but just that half of the triangle, is equal to the opposite side. And then just like before, since we only found it for the top side, we'll multiply it by 2 to get the entire thing, and that's the entire linear dimension of the single slit, or of the central maxima. Okay, so that's what we're looking at there. The central peak is defined by the dark fringe points up and down from it.